Hey, welcome back to Robbins Racing. So I'm going to do another quick video for you guys. I want to show you how you can calculate your speed of your RC car, and using this formula you can determine any changes that you make and what those changes will make to your car. So to jump right into this, what I want to do is I want to show you the math that we're going to use to do this. And I know this looks complex, but I'm going to explain each step of it. So basically what we're going to do, the first thing we need to know is the kV of your motor. Right? So, for example, we're going to use my Losi 8-scale buggy here. I've got an 1800 kV motor on that. The next thing you need to know is the voltage. In my case, I use a 3S or a 11.1 volt battery, 5000 milliamp 100C. However, the important thing to know is this battery charges up to 12.6 volts. So, if I know my kV is an 1800, and my voltage is 12.6 volts, my RPMs is 22,680. That means that my motor will turn 22,680 revolutions per minute at the rotor under no load. The next thing we need to figure out is the diameter of our wheel. So the diameter of this wheel I've already measured is 14 inches. Now we're going to divide that by 63,360, which is how many inches are in a mile. In this case, I come up with 0.0002 revolutions, or in other words, this is how far my wheel will go in a mile. Okay, so the next thing we're going to do is we're going to take our RPMs that we found, and we're going to multiply that by our revolutions that we found, which comes out to 4.35, which is miles per minute. .53 miles per minute. Okay. We're not here to discuss whether I'm dyslexic or not. I'm also reading upside down, but that's okay. I appreciate that. Thank you. All right. So the next thing we're going to do, we've got our miles per minute. We need to take our miles per minute, multiply that by 60 because there's 60 minutes in an hour. It's going to give us a speed of 271.8 miles per hour. I really wish my buggy went 271.8 miles per hour, but unfortunately it doesn't because of gear ratios. In this case, gear reductions. You have gear reduction between your pinion and your spur gear. You have gear reductions in your differentials, so forth and so on. So what we've got to do is we got to figure that part out, what our gear reduction is. Now, there's a very easy way to do this, and I'm going to show you guys this right now. Take a piece of paper, draw you a black line on that piece of paper, and line it up so that that black line is straight down your axle, just like that. The next thing you want to do is put you a nice mark on your pinion gear that you can see. In this case, I'll put a silver line on my pinion gear there. Now what I'm going to do is I'm going to start rolling my car until that silver line goes all the way one complete revolution. And once it does that, I'm going to come back and I'm going to draw another line on my paper right at that point, which is what we've done here. So once we've done that, I'm going to measure that distance with, you know, my nice handy dandy ruler here, tape measure. And in this case, I get 1.25. Now, the more accurate you are with that, the more accurate your numbers are going to be. But in this case, I got 1.25. Remember, if you do fractions, you've got to convert those over to decimal points. So 1 1/4 is what I measured, 1.25. So 1.25 divided by 14, which in this case was my wheel diameter, gives me 0.085. That's my gear reduction, or my roll, however you want to call that. So my gear reduction is 0.085. So 0.085 times my miles per hour, 271.8 equals 23.1. So this car, the way it's set up with these tires on it, and the pinion and spur gear that I have on this car, the motor that I'm running, and the battery that I'm running, will run 23.1 miles per hour. Now, one thing that's important is if you know this information with your RC car, what we just figured out, you can change things and see how that'll affect your car. For example, let's say you went to a larger kV motor and you input that larger kV into this formula, worked out the same information. At the end, this number you get is either going to be faster or slower, for example, and that's how you can determine if a different motor is going to have an effect on your car, or what effect it's going to have on your car. The other thing you can do, larger tires or smaller tires, is going to change the diameter of your tire. Then you can do this formula by changing that number and see if that's going to make your car faster or slower. Your pinion and spur gears, when you change those gears, that's going to change your rollout, right? So you can change those gears and you can figure out this number to see how that changes your speed of your car. So if you're trying to get more speed out of your car, you can change these variables in this formula before you buy those products, or once you buy them, to see what difference they're going to make in the overall performance of your RC car. So it's a good thing to work out anytime you get an RC car. Go ahead and work through this formula so you know what your car is doing, and then you can make those changes on paper to see what changes they're going to have in reality to your car. Very good information to have. It seems a little bit complex, but it's not really. Once you kind of do this a few times, you get comfortable with it. It's a great tool to have in your toolbox. Thanks for watching, and we appreciate it. Have a good day.